Okay, so we're trying to do the integral of 5 times 4 to the x dx. Well, it's the indefinite integral. It's the antiderivative, right? That's what integral means, is antiderivative. We want to do the antiderivative. That was a big discovery of calculus, was that integrals are the opposite of derivatives. So integrals are antiderivatives. Okay, well, to do that, let's remember what kind of form this is. This has to kind of jump off screen for you. You got to recognize that's exponential. What do I mean? Well, we know if you have x in the base, like x to the 10th, you know how to do the derivative. That's the first rule we ever learned, right? The power rule, just bring the 10 down, subtract 1, 10x to the 9. You know that. Whereas if x is in the power, like e to the x or 10 to the x, that's called exponential when x is in the power. And that's a different set of rules. E to the x is our favorite one. He does nothing, just e to the x, right? But 10 to the x, how about that? Well, that's going to do the same thing. At first, it does nothing, like e to the x, but then you multiply by ln 10. So when you do the derivative, you got to multiply by ln 10. So in other words, the general rule is if you have a to the x and you do the derivative, it's because notice if it's a number other than the perfect number e, it's going to be a to the x times the natural log of a. That's how we do the derivative. We multiply by the ln, and I'll just say the ln of a. Because e is the perfect number. If you have any other number in the perfect number, you got to have that adjustment. That's not chain rule. That's just how you do the derivative when you have something other than e in the base and x in the power. You just do nothing like e to the x, but then you have this little adjustment ln a. Okay. Well, we're trying to do the antiderivative. What do you think then? If you're going to go back and do the antiderivative, instead of multiplying by ln a, which is what you do for the derivative, what do you think you're going to do? You're going to divide by. Maybe I should just write the word divide by ln a. That's the opposite, right? We're going to divide by ln a for the antiderivative, right? If the derivative you multiply by ln a, then the antiderivative you're going to divide by ln a. So here we go. Come back in here. Now, what about that 5 sitting in the front? Who cares, right? Numbers in the front multiply and just sit there. But the 4 to the x, what's that going to be? It's going to do nothing, but then we're going to divide by ln of 4. That's the antiderivative. Divide. And that's it. There's nothing more to do. And you can see that is the answer, plus the constant, of course. And so there we go. So make sure you're clear when you see 4 to the x. That's exponential. X is in the power zone. That's different than like x to the 10th, right? Where x is in the base. X is in the power. That's like e to the x. That's exponential. The derivative does nothing, is our favorite one. But if it's for e, it does nothing. But if it's any other number than e, it goes times ln 10. So the antiderivative will divide by ln of that base. And there we go.